Hi everybody. So in this video I'm going to show you the property of intersecting chords. And to do this we're going to work through two examples. And in the first example we're told that the chords AB and CD intersect at P. So this is the chord A to B, this is C to D, and this is where they intersect. We've been asked to show that triangle APC is similar to BPD. And to prove similarity, we need to show that their interior angles are the same. So if we begin with this angle at P, we know these two angles will be equal because they are vertically opposite. And then if we construct two chords between A to C and D to B, then we have angles in the same segment at A and at D, this angle and this angle. And we can use the same idea for the angle at C and the angle at B. So these blue angles are equal and the green angles are equal for the same reason that angles in the same segment are equal. So we've proven that this triangle is mathematically similar to this triangle. So now what I'm going to do is sketch these two triangles separately. We know each of these two angles will be angle P, and then this angle we can get by rotating this triangle, then this will be vertex A, and this one will be vertex C. And then we can rotate this bigger triangle to the right, and then reflect it, so this will be angle D, and this will be angle B. Okay? So because the two triangles are similar, we know if we multiply each length in this small triangle by a length scale factor, we'll get the corresponding lengths in the bigger triangle. And we can work out the length scale factor by dividing one length by its corresponding length in the other shape. So this will be P to B divided by C to P. So PB divided by CP, this will be exactly the same as this length divided by this length. So PD divided by AP. And now we can prove this property by moving this AP to the left hand side and the CP to the right hand side. So AP multiplied by PB will be exactly the same as CP multiplied by PD. And this is the property we were asked to show. Okay? Let's look at our second example. Okay, so in this example, we've been told that the extended chords A to B and C to D, so A to B here and C to D here, intersect at point P, which is this point here. We've been asked to show the same property. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So the first thing we're going to do is we're going to draw two chords again. One from A to C, and one from B to D. So now we have two triangles. We've got a small one from P to D to B, and we've got a bigger one from P to C to A. And we know that this angle P is common to both triangles. And we can also see that this quadrilateral ABDC is a cyclic quadrilateral. And this means that the opposite angles add up to 180 degrees. So if we call this one angle A, the opposite angle here will be 180 minus A. And if we call this one angle C, then the angle at B will be 180 minus C. So if this angle is 180 minus A, then this angle would be 180 take away this, so just A. And the same is true for the angle at B, this would just be C. So again, we've proven that the two triangles have the same three angles. So if I sketch each of them as separate triangles, and if we swing this triangle to the right, then this angle will become angle D, and this will become angle B. we can do the same in this bigger triangle, and then we have to flip it. Then this becomes angle C, and this one becomes angle A. So again, we can find the length scale factor as the big length divided by its corresponding little length. So A to P divided by P to D will be exactly the same if we use these two lengths, P to C and P to B. So C to P divided by P to B. And then we can move this term to the right hand side and this term to the left hand side. So we get AP multiplied by PB will be equal to CP multiplied by PD. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.